Hello everyone. Today I will defend my report uh, 3 and 4. Uh, Starting with report 3, it's from 8 till 10 modules. So I will defend my 9.2.9 Cisco packet tracer. So here is we started with the pinging to the IP. So we are pinged computer 1631.1 to 1631.2. So it's successfully pinged. As we can see, it's sent 4 and received 4, so there is 0% of loss. After that, we moved the created PDUs to the switch 1 by clicking to the next button. So the PDU disappears in 31 and second from computer, and it goes to the switch 1. As we can see, it's on the switch 1. So there is a PDU information. So there is in the outlayers we can see the destination IP. It's 172.16.31.3. If we put next after the switch, it will go to the point 172.16.31.3. It's this computer in the middle of the right side. So after that, we are as you can see, it is sending. So it's sent to the 31 and third one, 34 first and fourth one, and to the router 1. So it's divided to 3 parts. It is successfully divided for 3 parts, but we have a problem that it's labeled with red X. In the third one it's correct, but in the fourth and router first it's incorrect. And where change the MAC address of it. As we can see, it is destination place and IP where it came from. It came from second, as we can see, and we're get it back this everything by clicking to the next one again, and then it goes back and disappears everywhere, but came to the second computer. So we are started to check the destination and the MAC address correctness. As we can see, the destination place 1DA7. So it's the here is 1DA7. In the end, it's the second one with the last second number. So it's this our first computer. And 2849. 2849 it's destination address. As you can see, it's the third computer. Yes, it was the third computer. So we're started to pinging it to the fourth computer with the end of the fourth. The ping it is pinged correctly, so it's sent for and received for, and 0% of loss. Pinging receive and send, it's 0% lost, and it's fully pinged. And so it's the corresponding addresses. We put the command in the switch 1. It's show MAC address table. So it's shown us the MAC address table, and there is a MAC address of VLANs and types. There is a port. As you can see, it is the same and correct with the table that was given in this assignment. It's for example, FA03, it's 8G75, so it's also 8G75. FA01 01, it's 1DA7, it's also correct, and the others is also correct. And we make the same thing in the switch 0. So it's switch 0 show MAC address table, and we show the MAC address table. We pinged it. We firstly wrote the ARP minus A to check, and then we started pinging it to 10.10.10.1. 10.10.1, it's our uh, switch, sorry, computer, where started to, we pinged it, it was correctly, and it's also pinged and received fully, and we're started to make the new ICMP ARP. So we can see it's uh, fully done, and it's correctly created, and also make the button to the right side. Next, it goes to the switch 1, and as we can see, its target destination, it's fully correct. And we're go to the privileged mode of to show ARP. It's again, we wrote the enable and come to the privileged mode. It's in the hash and show MAC address table. Where show the MAC address table, as we can see, it's also type ARPA. It's correct. My fourth report, it's about topics of 11 and 13. So it's the network and host portions. Like an IPv4 address is a 32-bit hierarchical address that is made up from a network portion and a host portion. When determining the network portion versus the host portion, you must look at the 32-bit stream as shown in figure. As we can see, it's fully shown. The bits within the network portion of the address must be identical for all devices that reside in the same network. The bits within the host portion of the address must be unique to identify a specific host within a network. If two hosts have the same bit pattern in the specified network portion of the 32-bit stream, those two hosts will be reside in the same network. So the subnet mask, as shown in the figure, um, in this figure, the IPv4 address, this is the unique IPv4 address of the host, and subnet mask, this is used to identify the network host portion of the IPv4 address. For example, configuration of IPv4. It's our IPv4 subnet mask and default gateway. So it's the prefix length. So it's subnet mask, and it's in the 32-bit addresses, and the prefix length it's 8, 16, 24, and etc. till 30, as you can see. And when we're representing an IPv4 address using a prefix length, IPv4 address is written followed by the prefix length with no space. For example, it's, as we can see, it can be written in this way. Using the various types of prefix lengths will be discussed later. For now, the focus will be on the 21 prefix. Determining network and logical end. For example, a logical end is one of the three Boolean operations is used in Boolean or digital logic. The other two are or and not. The end operation is used to determining the network address. For example, 1 and 1 it's 1, 0 and 1 it's 0, 1 and 0 is 0, and 0 and 0 is also 0. It's in the simple way, it's like a Kubitu. So it's also in there you can see the IPv4 host address. The IPv4 address of the host is dotted, decimal, and binary formats, and subnet mask of the host is denoted in decimal and binary formats also. Network address, the logical AND operation between the IPv4 address and subnet mask results in an IPv4 network addresses shown in dotted, decimal, and binary formats. As you can see, here is the decimal and binary formats and equals. So network host and broadcast address. Within each network there are three types of IP addresses. It's network address, host address, and broadcast address. Using the topology in the figure, and these three types of address will be examined. As you can see, it's these three types of topology examined. So it's also our project, And broadcast address. Broadcast address is an address that is used when it's required to reach all devices on the IPv4 network. As shown in the table, the network broadcast address has all 1 bit in his portion as determined by the subnet mask. In this example, the network address is as shown. A broadcast cannot be assigned to a device or as a device. Coming to the multicast. Multicast is transmission reduces traffic by allowing a host to send a single packet to a select set of hosts to subscribe to a multicast group. So multicast packet is a packet with a destination IP address, and that is a multicast address. IPv4 has reserved the, as we can see, 224.0.0.0 to 239, 255, 255, and 255 addresses as multicast range. So routing the internet. Most internal network from large enterprises to home networks uses private IPv4 addresses for addressing all internal devices, including hosts and routers. However, private addresses are not globally routable. So there is in this figure, it's private IPv4 addresses and network addresses translation. So there is a special uses of IPv4 address. There is such as network address and broadcast address, and that cannot be assigned to host. There are also special addresses that can be assigned to host, but with restrictions on how those hosts can interact within the network. It's loopback addresses. So there we can see the pinging of the loopback interface. So it's also pinged, 0 lost, and 0 sent and 4 sent and 4 received. Legacy classful addressing. There we can see classes and division for classes. So so we can see the division of regional internet registers. And I guess that's it. Thank you for your attention.